Okay, so welcome to another lesson. So for this video, we will be discussing the derivatives of exponential functions. Okay, so when we say exponential functions, so those are functions for which the exponents are variables. Okay, so say for example, if you say x squared, okay, so when you say x squared, that is only an algebraic function. Okay, this is algebraic. But when we say 2 raised to the power of x, this is already exponential. Okay, so see the difference. So in exponential functions, the exponents are variables. Okay, so for cases where we have a raised to u, where a is any constant, any non-zero constant, a is not equal to 0. So we have the derivative of a raised to the power of u with respect to x is equal to a to the u ln of a multiplied by du over dx. Okay, and when we have e to the u, so its derivative with respect to x is equal to e to the u multiplied by du over dx. Okay, so these formulas are actually derived from the derivatives of logarithmic functions. So particularly, it's called logarithmic differentiation. Okay, so let me get another sheet of paper. So it's called logarithmic differentiation, where for us to be able to differentiate a function, so we will take the natural logarithm of both sides. Okay, so say for example, we have find the derivative of y is equal to a raised to u. Okay, so what we actually do is we take the natural logarithm of both sides of the equation, so it will become ln of y is equal to ln of a raised to u. And since this is a logarithmic function, then we can apply the properties. So the exponent of a will be transferred in the coefficient side, so it will become ln of y is equal to u ln of a. So remember, a is a constant. Okay, and then next, so we will derive this implicitly. So derive ln of y with respect to x, and derive u ln of a with respect to x. So the derivative with respect to x of ln of y is equal to derivative with respect to x of u ln of a. Okay, so deriving ln of y with respect to x, so it will become so the derivative of y, so from the formula in the previous lessons, it's equal to 1 over the derivative with respect to x of ln of u is equal to 1 over u times du over dx. So in this case, our u is equal to y, therefore this will become 1 over y times dy over dx is equal to ln of a is a constant, so you can write that outside of the derivative sign, and then the derivative of u with respect to x, so that is du over dx. Okay, so since we are looking only for dy over dx, so therefore dy over dx is equal to y ln of a times du over dx. Okay, but since y is equal to a raised to the power of u, so therefore dy over dx is equal to a to the u ln of a and then du over dx. Okay, so this formula is this one, first formula. Okay, so similarly, you can also solve for the derivative of e raised to u, and you will see that it's this. So e to the u multiplied by du over dx. Okay, so that's This process is called logarithmic differentiation. Okay, so where we get the natural logarithm of both sides, okay, of the equation, so that we can differentiate. Okay, so those are very simple formulas that you should be able to memorize. Okay, you have to memorize these formulas. So let's apply those formulas in some examples. So number 1, find the derivatives of the following. Y is equal to e raised to x squared plus 3x. So obviously this is indirect use of the second formula. So the derivative of e to the u, okay, is equal to e to the u times du over dx. So our u here is x squared plus 3. Okay, so solution for letter A, so you have y is equal to e raised to x squared plus 3x. Okay, so its derivative with respect to x, okay, so the derivative of y with respect to x is equal to, so all we need to do is use this formula. So copy e to the u, so e to the u is e raised to x squared plus 3x. Okay, and then multiply that with the derivative of the exponent. Okay, so the derivative of the exponent with respect to x, we have derivative of x squared plus 3x, that would be 2x plus 3. Okay, so therefore our derivative now is this, so 2x plus 3 and then e raised to x squared plus 3x. Okay, so it's that simple. Okay, so it's the easiest type of derivative. Okay, so because you don't have to memorize a lot, all you need to do is copy this and then just multiply it with the derivative of its exponent. Okay, so similar with the first formula, so all you need to do is add the natural logarithm of the base. Okay, so example number 2, we have y is equal to 2x plus e raised to x squared raised to the power of 4. So y is equal to 2x plus e raised to x squared raised to the power of 4. Okay, so this for this problem, we will be applying the general power formula, where our u is this whole equation or this whole expression inside the parenthesis. Okay, so following the general power formula, our dy over dx is equal to, so bringing that down, it will become 4 times 2x plus e raised to x squared raised to 4 minus 1 multiplied by the derivative of the expression inside the parenthesis. So the derivative of 2x with respect to x, so that is 2. Okay, so 2 times derivative of x, so that is 1, and then plus derivative of e raised to x squared. So from the formula again, so just copy and then multiplied by the derivative of the exponent. So copy e raised to x squared, multiply it by the derivative of x squared, okay, which is 2x. Okay, so that's it. Simplify. So we will have the derivative is 4 times 2x plus e raised to x squared raised to the power of 3 multiplied by, so simplifying this will become 2 plus 2x e raised to x squared. Okay, or you can factor out 2 in here, and then 2 times 4, so it will become 8 times 2x plus e raised to x squared cubed. So what will remain here if we factor out 2 is 1 plus x e raised to x squared. So this is now our derivative. Okay. So next is we have the third one, letter C. Copying, we have y is equal to x times 5 raised to 3x. Okay, so obviously for this we will be using the first formula where a is any constant not equal to 0. So in deriving this, as you can see, we have a product, so therefore we will be using the product rule. Okay, so dy over dx is equal to, so the first factor multiplied by the derivative with respect to x of the second, so derivative of 5 raised to 3x plus 5 raised to 3x, so the second factor multiplied by the derivative with respect to x of the first one, which is x. Okay, so this will now become x. So the derivative of this following the formula, so we will copy a to the u. So a to the u is 5 raised to 3x multiplied by ln of a. So our a here is 5. So times ln of 5 and then times the derivative of u with respect to x. So our u here is 3x. So the derivative of 3x with respect to x, so that is 3. Okay, and then plus 5 raised to 3x, derivative of x with respect to x, that is 1. Okay, so therefore we can rewrite this now. So 3 times x times ln of 5, so that is 3x ln of 5 times 5 raised to 3x. Okay, plus 5 raised to 3x. So we can factor out 5 raised to 3x since it's a common factor. So dy over dx is 5 raised to 3x multiplied by 3x ln of 5 plus 1. Okay, so that is now our derivative. Okay, so for the fourth example, so we have y is equal to ln of x plus 5 e raised to 3x. Y is equal to the natural logarithm of x plus 5 e raised to 3x. Okay, so following the formula for natural logarithm, so dy over dx is equal to 1 over u. Our u from the formula is x plus 5e raised to 3x. So it will become 1 over x plus 5e raised to 3x multiplied by the derivative of u with respect to x. So just derive x and x plus 5e raised to 3x. So derivative of x, that is 1 plus, we have 5 multiplied by the derivative of e raised to 3x. So that will be multiplied by e raised to 3x, copy, and then multiply it with the derivative of the exponent 3x with respect to x. So that is 3. Okay, so therefore dy over dx is equal to, simplifying, it will become 1 plus 3 times 5, that is 15. So 1 plus 15 e raised to 3x over x plus 5 e raised to 3x. Okay, so it's very simple. The last one for our final problem. So find the critical points and identify as either local maxima or minima, and I forgot to write the problem. Okay, so this is the function f of x is equal to x e raised to the negative x. So find its local maxima or minima. Okay, so for letter E, we have f of x is equal to x e raised to the negative x. Okay, so we need to find the local maximum or minimum. So we will derive the function, okay, and then equate the derivative to 0. So f prime of x using the product rule. So this is first factor multiplied by derivative of e to the negative x. So the derivative of e to the negative x is copy times e to the negative x multiplied by the derivative of the exponent. So the derivative of negative x is negative 1. Okay, plus copy e to the negative x for the second factor multiplied by the derivative of the first factor. So the derivative of x is the derivative of x with respect to x, the derivative of x with respect to x, so that is 1. Okay, so therefore equating this to 0, so simplifying, so we have negative x e raised to the negative x plus e raised to the negative x is equal to 0. Okay, so factoring out e to the negative x times factoring, so we will have negative x plus 1. Okay, so it's equal to 0. Then we will get e to the negative x is equal to 0, and negative x plus 1 is equal to 0. So here we will get x is equal to, okay, so I'm sorry, so here we will get x is equal to 1, and then on the other side we will get, this is mathematically, so this is what do you call this? This cannot be solved mathematically, but using the concept of calculus, so we will see that the value approaches to infinity. Okay, so x approaches infinity. So to solve for x, we can apply the negative logarithm, we can take the natural logarithm of both sides. So ln of e raised to the negative x is equal to ln of 0. Okay, so as you can see, ln of 0, if you use your calculators to solve for ln of 0, so it is ln of 0. It's math error. Okay, So, but using the concept of calculus, the value of ln of 0 approaches to negative infinity. Okay, so negative, applying the properties of natural logarithm, so negative x ln of e is equal to ln of 0. So ln of e is equal to 1, so therefore x is equal to negative ln of 0. Okay, and again, it's math error because this is under the concepts of limits. Okay, so its value actually is x. It's not equal, but it should be approaches. Okay, so value of x approaches negative the value of ln of 0 as the value of ln of 0 approaches negative infinity. Okay, so x actually approaches positive infinity. Okay, so since we are only looking for the local maximum or minimum, so we will only consider this one point. Okay, x is equal to 1, but we don't know yet if it's normal maximum or minimum, so therefore we need to perform the second derivative test. Okay, so our first derivative being f prime of x is equal to from here, so this is our first derivative, right? Negative x e raised to the negative x plus e to the negative x. Okay, so our second derivative now is we will derive this. Okay, so we can separate the negative, or we can combine it with the first term. So first factor is negative x multiplied by the derivative of e to the negative x, so that is e to the negative x times negative 1 plus the second term e to the negative x multiplied by derivative of the first factor, derivative of negative x is negative 1. Okay, plus the derivative of e to the negative x is e to the negative x times derivative of the exponent negative 1. So therefore, if we simplify, the second derivative is positive. It will become positive x e raised to the negative x, and then minus, this will become minus e to the negative x, and then minus e to the negative x, so minus 2 e to the negative x. Okay, so this is the second derivative. So at x is equal to 1, so substituting, this will become 1 times e raised to the negative 1 minus 2 e raised to the negative 1. So therefore, the value of the derivative will be similar terms, so it's negative e raised to the negative 1. Okay, so since the value of the derivative is less than 0, so therefore this is a local maximum. Okay, so therefore you can just write here a final answer. So answer, local maximum, okay, at x is equal to 1. How about y? So at x is equal to 1, this will become 1 e raised to the negative 1, so it will become e raised to the negative 1, so therefore it's 1 over e. Okay, so therefore its local maximum is at 1 and 1 over e. Okay, so expect you might also encounter some problems involving tangents and normals. Okay, so you also have to review it, so all of it still uses the derivative. Okay, so that's all for this lesson. So good luck with your assignments and your examinations.